So while I said the substitution method was a wonderful method to solve algebraically a system of equations, I'm particularly fond of the addition or the elimination method as well. I don't know why. I just think it's because you have to see factors and numbers, and so anyway, here's the steps, and I think I'm going to refer to this problem as we go. So step number one. Rewrite each equation in standard form. That means the x and the y terms need to be on the left side and the constant on the right. See these two equations? The x and the y are on the left and the constants are on the right. They're also in order. X is our first, y is our second. If necessary, multiply each equation by a constant. That just means a number, so that the coefficients of one of the variables will add up to 0. So do you see this letter y? The coefficients of the letter y in question number 10 are 1 and a -1. They are already ready, and their coefficients will add up to 0. So step number 3 is to add the two equations to eliminate a variable. So I'm going to go ahead here and do that. So you just add, remember this is equal to this, and this is equal to this. So when you add the left sides and add the right sides, you're adding equal things. So this 1x and this 2x adds to be 3x. This 1y and a -1y is gone. 11 and 1 adds to be 12, and then you solve for the variable that's left because you eliminated by the addition method one of the letters, and x is equal to 4. Then you go into one of the two equations. I'm going to go into this one because it was a simple one. It was x plus y equals 11. And so if x is 4, then y looks like it has to be 7. And I am all done. So x is 4, y is 7. Again, please don't forget, and I can't say that I'm going to do this every time, but don't forget, check even in the equation you just used. So that equation said x plus y equals 11, so see if 4 plus 7 equals 11. And then 2 times x, so 2 times 4, minus y, which is 7. Does that equal 1? So does 8 minus 7 equal 1? It sure does, so I know I got it correct. So I solved one of the equations for the letter x. I substituted that value into an original equation to solve for the other letter, and then I checked the solutions for the variables in both equations. Okay, so this problem right here is not in standard form. So you see this x that's on the right hand side? I'm going to transpose it and move it over to the left side and make it a negative x next to this 4y. So I've moved it. So I have now a negative x plus 4y equals 7 and a positive x plus 3y equals 7. So, son of a gun, isn't that nice of me to make this be a -1 and this be a +1 so that when you add these equations, the x's disappear, and 4y and 3y add to be 7y. 7 plus 7 is 14, and now when you divide both sides by 7, you get y is equal to 2. Take that value for y and plug it into one of these two equations. For whatever reason, this equation is calling to me because x is just a 1x. And so if I put in 3 times y, I can quickly solve for x. I can see right now x has got to be 1. You don't need to write this step right here that x has got to be equal to 1. And finally, would you write as an ordered pair that x is 1 and y is 2? And would you be sure to go and check it in these two equations? I'm just going to erase this right now. And 4 times 2, that's 8. Is that equal to 1 plus 7? Yep, that's 8. 1 plus 3 times 2? Yep, sure enough, that's equal to 7. Okay, so let's, what happens now when the coefficients in front of a variable are not the same? So what I have here is I have a 2 in front of the x and a 3 in front of the x. Those aren't the same. I have a 2 in front of the y and a -1 in front of the y. So I like the thought of working with the y's because this one's plus and this one's minus. So when I go to add these, if I could have this be a 2 and this be a -2, then they would add to disappear. So I'm going to come on over here and I'm going to say that I'm going to multiply equation 2 by the number 2. And I'm going to bring that down in red. So this is going to become 6x, 3 times 2. This is going to become a minus 2y. Don't forget, you got to multiply the 1 times a 2 and get a 2. And then I'm going to copy equation 1 down. So right here, I'm going to copy equation 1 so that they're side by side. So I've done nothing to this problem but multiply both sides by the same value, which means it's still a true statement. But now this minus 2y and a positive 2y will add to be 0. So I'm going to add the above two statements. I'm going to abbreviate that as statements. So 6x and 2x adds to be 8x. These y's cancel. 2 plus 2 is 4. And when I divide both sides by 8, I get x equals 1/2 when I reduce that. Let's see. If I'm going to put x equals 1/2 in either here or here, it looks nicer to put it in here because 2 times 1/2 is 1. So I'm going to go over here and substitute in that 1/2 for x so that I can solve for y. So again, 2 times 1/2 is 1. And so I have 1 plus 2y equals 2. And I'll subtract 1 from both sides. And 2y equals 2 and a negative 1 add to be 1. And now I'll divide both sides by 2. Wow, so x is 1/2 and y is 1/2 in this problem. If I wanted to check that on my graphing calculator, you know what I would probably do? I'd probably just type in over here 2 times 0.5, because that's easier for a half, plus 2 times 0.5, and I want to see if that's equal to 2. And then the second equation, 3 times 0.5 minus 1 times 0.5. I didn't need that 1. And I want to see if that's equal to 1. And I've done my checking. You don't have to show me the checking. You have to do it for yourself. So you can say, oh good, I'm really happy with my results. Okay, let's see if we can get this problem done. Now this one's not so nice. I can make these become 10s by multiplying this equation by 2 and this equation by 5. But right now their signs are the same. So I'd have to multiply one of them by a negative number to make their signs opposite. See the 3 and the 5? The common multiple between a 3 and a 5 is the number 15. And this is a way to find a common multiple, is to list multiples of 3 and 5. As a result, and I'm going to do this in color, I'm going to multiply this equation by the number 5. So let's go ahead and do that. So 5 times 5 is 25x. 3 times 5 is 15y. And 19 times 5 is 95, it looks like. I'm going to check that real quick in my head. Yeah, 95. Then I'm going to multiply this equation by the number 3 so that this will become a minus 15. So 2 times 3 is 6x. A minus 5 times 3 is a minus 15y. Notice those y's. Good. 11 times 3 is 33. And now I can add these two equations. Well, this adds up to be 31x. The y's are gone. And 95 and 33 adds to be 128. And then I want to divide both sides by 31. And I get my answer. And I personally don't care to turn that into a mixed number. I just want to leave it. I don't care what it is. Secondly, I love fractions. I wouldn't mind putting that in for x in one of these two. But I want to tell you, if you don't like fractions, we could start over again with the original system. And we could make the x's disappear this time. I just want you to know that that's an option if you don't like fractions. So I'm going to multiply the top equation by 2 in order to make this a 10. So that'll be 5 times 2 is 10x. This 3 times 2 is 6y. And 19 times 2 is 38, pretty sure. Then I'm going to multiply the bottom equation by a -5. Now I'm doing a -5 this time because 2 times a -5 will give me a -10x. And I want those to eliminate when I add them together. But be careful, this -5 times this -5 will be a +25. And then 11 times a -5 is a -55. And when I add these two equations now, I'm going to get 31y. Again, the x's disappear. 38 minus 55 is, I think, 17 negative. And then I divide both sides by 31 to solve for y. And so y is equal to a -17 over 31. My ordered pair is 128 over 31 and a -17 over 31. And I'm going to see if I can grab my calculator here. And I'm going to have to just remember the other fraction. So right here, I'm going to go 5 times 128 divided by 31. And then plus 3 times, and y was a -17 divided by 31. I'm cheating, you know, I just don't want to deal with the fractions, and I want to know if that equals 19. That's close enough. Oh, and you know what? It probably would be 19 if I had typed a 31 right here. I typed a 17 divided by 30. I bet it would be exactly 19. So I was kind of surprised, to be honest. 2 times, I'm doing the second equation, 128 divided by 31. And then right here, -5 times y. -5 times, and y was a -17 divided by, I'm going to do the 31 this time. And I hope that's going to be 11. Exactly, so it was supposed to be 11. I'm sure that one would have turned out to be 19. I'm going to stop there. This is solving a system of equations by elimination. We'll come back and start up with number 14. You might try that on your own while you're waiting.